All right, how's everybody doing this afternoon? That well, huh? Yeah. Got to get the energy up after lunch, right? Everyone's going to go into a food coma. My name's Ben Lauer, and I'm a program manager, PM, on the Kinect for Windows team at Microsoft. And does everybody in here know what a PM really does? It's kind of different company by company. The explanation that I've heard that I think is the best one is a PM is somebody who's not smart enough to be a dev, not pretty enough to be in marketing, and not mean enough to be in test. So I'm sort of in the middle of things. My main function on the team is to do our developer outreach and evangelism and marketing. But I used to be a developer in a former life, and so I'm going to take you guys through my talk today, which is called Kinect Interactions, Get a Grip in C# or HTML JavaScript. So just by way of showing hands here, how many people in the room consider themselves primarily a web developer? All right, cool. So hopefully you guys are going to like some of the stuff that we're showing here today. So our agenda today is I'm going to introduce something that we came up with on the team that we call the periodic table. And if you're already doing a lot of Kinect development, this will be a review for you at the beginning, but I think it might give you a new way to think about some of the data that comes off of the sensor. I'm then going to spend a good chunk of time talking about something that we introduced in our most recent SDK back in March, the 1.7 SDK, called the interaction stream. I'm then going to talk and give a sneak peek of the next version of our SDK, which is going to come in September, version 1.8. And then I'm sure there's probably some people in the room that would love to hear something about the new Kinect. We've talked about and shown off the Xbox One and the new Kinect for Xbox One. My team is going to have a new version of Kinect for Windows coming out next year, and so I'm going to talk a little bit about that, and then I'll save time at the end for Q&A. Does that sound good? All right. So this periodic table, I think everyone in the room should recognize this from science class, yes? Periodic table of the elements. So kind of stealing this as an idea a little bit. Oh no, it's Chuck Norris. And he had to destroy the periodic table because he only recognizes the element of surprise. Oh, come on, come on. So in all seriousness, regardless of what Chuck Norris has to say, we're going to steal this idea. And what I'm going to introduce is this. We have these things that we call like sort of the fundamental building blocks of Kinect, the data streams. And I'm going to talk through these in the next slide. So we have a stream symbol, stream name, and then the data type for these streams. And these are the 5 streams. So again, if you've done Kinect development before, you're familiar with this. The depth stream, this is what it looks like. So this is me captured with a Kinect and just showing the visualization of the depth. So we detect a person, and that's me with my outline there. Just to show you it's the same photo, the exact same capture, this is the color stream that comes off of the camera. So you can see it's the same pose there. We have an audio stream. So this is the best image I could get of my voice showing up there. We have infrared, which allows the Kinect to see in the dark. And then we have an accelerometer, which for most development purposes is not going to be super interesting unless you're trying to mount the Kinect in some weird way. That's going to cause other issues. But this does tell you the orientation of the Kinect in XYZ space. So then we take those eyes and ears, if you will, those fundamental data streams, and we then build what we call the recognition streams on top of that. And this is think of the recognition streams as sort of the brains. And down here at the bottom, you can see I'm showing these recognition streams and upon which other streams they're built upon or from where they derive their information. So skeletal tracking, this is that same color that we saw a second ago with my skeleton mapped onto my body. So how many people, just by the way, have not really done Kinect development at all? Okay, so fair number. Okay, good. So I'm not boring you guys to death, I hope. So with the skeleton, we give you 20 joints that are mapped to the body. So you can see these. Our docs spell this out really well. You can see that my legs here are occluded just because of the angle of the Kinect. But skeletal tracking uses that depth data to do its magic and then return the skeleton for up to 2 people simultaneously. Speech is built upon the audio. Face tracking is fairly complex, and it actually uses skeletal tracking to find your head or your user's head, and then we use depth and color to then return back a mesh on your face. And we give you 87 distinct points on the face for face tracking. So if you haven't done it yet, I'm going to say this again at the end of the talk to remind you, but you should download our current SDK. We have some great samples in our toolkit, and you can play around with this and see, like if I raise my eyebrows or if I smile, you can see this mesh will respond to that, and you can use that in your applications. Kinect Fusion, we've got a talk today at 5 o'clock. My colleague and teammate Chris White is going to talk more about Kinect Fusion, and he's going to talk about some of the new things in 1.8 around Kinect Fusion. But this was something we just introduced in our 1.7 version, and this allows you to take a Kinect out, scan a person or your pet, if they hold still long enough, or your environment, and we generate a 3D point cloud. And then you can take that, you could put it into CAD modeling software, or you could send it to a 3D printer. There's tons of 3D printers around at the conference with the announcement with the new print driver or print support in Windows 8.1. But Kinect Fusion is really awesome. And this is me doing a quick scan of myself to show what that looks like. And then what we're going to talk about for most of the talk today, interactions. And again, this is something new that came in 1.7. And I'm not saying talk to the hand here, but this is the cursor visualization that we spent a lot of time coming up with through tons of user research and tons of iteration. And we build upon skeletal tracking in depth for that. So those are our kind of eyes and ears and brains of Kinect. So what I want to do is I actually want to just show a couple of quick demos. So these were new demos that we shipped in 1.7. And the first one I'm going to show is called Controls Basics. So anybody in here have an Xbox 360 at home with a Kinect? So quite a few of you. So you're probably familiar with the interaction model in Xbox 360 where you move your hand over, you hover on an object, you wait for the ring to kind of go around your hand, and then the selection or the action occurs, right? So we wanted to do better than that. And so this is a sample that we shipped. So as you can see here, there's quite a few things going on. Notice, first of all, at the top in the center, this is a control we ship called the user view control, and it gives immediate feedback to me as a user that the Kinect is seeing me and exactly what it's seeing there. So this is sort of the model here that's in the original, or the Xbox 360, where you would kind of hover to scroll. But what we've done in 1.7 with interactions is we now allow you to just extend your hand out and do a press. So we ship these button controls. You can see the buttons actually change. There's a visualization that happens to indicate that they're pressable. And then if you notice there, as I slowly push my hand in, I get that visual feedback of the cursor letting me know how much farther I have to go. And then upon a successful press, it becomes blue, and so that I know that it was successful. So the other thing that I wanted to show you is I want to show you a sample that we call Interaction Gallery. And again, the source code for these samples is fully available in the toolkit. I recommend that you download it, take the code, play around with it, use it to get started with. So Interaction Gallery, think about if we wanted to have a kiosk maybe in our lobby at work, or a retail kiosk in our store. The situation here is the kiosk can just be displaying information, ads, content, video, whatever it is. So just kind of cycling through. And then as the Kinect detects a person, my silhouette comes up, and I'm sort of, oh, hey, it kind of sees me here. Lift your hand. So as I raise my hand, again, we detect that, and now I can start interacting with this gallery of information. And this is just something that we've put together to kind of show what you might do. I could have videos or photos. But the other thing that we added in 1.7 was this ability to have direct manipulation of the canvas. So I can simply grab, and now I can actually scroll and manipulate the canvas directly. And so again, in Xbox 360, I would be moving my hand over to the side, hovering over a scroll button for some amount of time, and frankly, that was just a frustrating way to interact. You couldn't get better. The expert user, if it was your 51st time using it, it took you the same amount of time as the first time using it. So we've got another example in here, this pannable map, which is cool, because again, it shows that you can actually just grip and scroll in X, Y space. Okay, so those are just two samples that we shipped to really show you what these interactions are about. So the interaction stream, let's talk about this. Why did we do it? Well, I think I spoke to that a little bit in explaining the samples there. But one thing I didn't mention is that we see that we're moving into a world that's multimodal. I mean, this laptop that I have right here has a touchpad, it has a little pointer nub thing, has a keyboard, and a full touch screen. So there's, keyboard, mouse, and touch screen right here in this. So Kinect is now enabling you to interact at a distance and to use touchless gestures and touchless interactions and in completely new ways. And we think that we're going to continue to see more and more experiences that blend all of these modalities together. The other thing that we saw with building the interaction stream is that it allows things to feel more natural. That hover thing that we did with the 360 was a good start, but we knew we could do better, and we think that just pressing is much more natural. Gripping is much more natural. And then finally, we did it because we know it's hard. And if you attended Allison's talk yesterday, he was on our team, helped build out the machine learning and all the work that went into building the grip recognizer. It was a lot of work, and it was a really hard problem to solve. And we did it so that there would be consistency across applications. We saw different developers trying to implement their own UI and interaction models. And so we said, no, let's standardize this. So then as we see more Kinect experiences built, users will have familiarity as they move from the one that Joel creates versus the one that Lance creates, right? We'll see that consistency across them. So let's talk about the interaction stream a little bit more in detail. So we have this concept of the thing that we call the fizz. At Microsoft, we always love to make up these TLAs and FLAs and everything, right? So the fizz is the physical interaction zone. And I have another slide on this to talk about in a little bit more, but this is a key thing as far as interactions go. We also track and recognize the hand cursor and then the press action. And I didn't really show it, but sometimes we'll see people and they'll get their hand into position and they'll already have their arm fully extended. And so we actually can recognize the press based on where you start the press. So if I start way back here, it'll still work. And if I start out here, I can do this, or I can even just do this with my hand and it'll work. We also do this thing where, I don't know if you saw it, but as I pushed my hand onto the button, the cursor would actually move into the center. And we discovered this through our many rounds of user research that, one, it really helped accuracy. If I was on the edge of a control and I started to press, I might fall off of it, right? So sucking the cursor into the middle helps with accuracy, A, but it was also kind of unexpected, but users really, really liked the satisfaction of hitting things perfectly every time. And it was something, again, it just came through all the rounds of research and tweaks and iterations that we did. And then finally, recognizing the grip and release gesture. If you didn't see Allison's talk, watch it streamed off of Channel 9 later, because it's really impressive to just hear like all the work that went into it and how we used machine learning and just tons of tagging and training data to come up with that grip recognizer. I will say that there's one distinct thing, that if you have people that point their hand out like this at the sensor and they try to do grip and release, we're not going to work well there, because the Kinect just sees the tips of the fingers and then the knuckles of the fist. So generally, if people are oriented in a vertical manner like this, it's going to work really well. So I talked about the fizz. So I've heard different explanations and kind of metaphors used to try to explain what this is. But the fizz is really, it's ergonomically designed to human movement. So if you put your arm out in front of you, most people actually don't move their arms in the way that a mime trapped in a box does, like a perfectly horizontal line, right? If I put my arm out and I move it, it moves in an arc. And that's horizontally as well as vertically. So you can think of the fizz as this area. There's actually one for each of the user's hands, and it's actually like a curved plane of glass right? And the fizz actually scales based on the user's height and the user's size. So we have here, this is an image from our HIG, which you can download on our website. It's a massive document that explains like all the UI and UX concepts that you need to be familiar with to build a really great Kinect experience. Let's see, anything I missed on this that I wanted to cover? Oh, I was going to say that I've heard it described as, if you think about where people would do sign language, kind of in this area, this is a good area for users to interact in. If you're doing gestures that require people to do like really big movements, they're going to get fatigued and tired and probably annoyed. So I talked about this a little bit. The old way, on the left-hand side there, the sort of hover and hold and hope that the circle completes before your hand slides off, versus the new way of targeting with the hand and then pressing to select. So this is the new interactions model, targeting selection. I think I skipped. OK, so the press cursors. This visual cue thing, I want to emphasize again that it's really important for people to get that feedback. If I'm using my hands to touch, or I'm using a mouse and I click the button, like that's very good feedback for me to know if did my finger actually press down and get that click sound on a mouse. So this visual feedback was really essential to have people have a good experience. So the hand cursor changes when it rolls over a pressable target. And then you can see there's the two examples of it filling halfway up, and then what it looks like when it's totally full and then complete. We also did this thing where if I fully press and I get that sort of cyan color for complete, if I move my hand, I can cancel. So just the same way you can with a mouse, where you would click the button, and if you move your mouse off the target, you can cancel a mouse click. We implemented that same logic. So scrolling and direct manipulation. I talked about it when I was showing the controls gallery, where you would hover over those scroll buttons, and now with the grip, you can get that direct manipulation. You just target anywhere with your hand and then grip and then manipulate the canvas. So again, just kind of showing these cursors that we've developed. So APIs. And I've got an architecture slide that I'm going to get to next. But we've built this interactions in a way that as long as you are using a language that can call C methods or call COM, you can use the interaction stream from Kinect. So we have this native COM component, and we essentially then build on top of that a managed .NET wrapper so that you can use it in C#, VB, any .NET language that you would want to do. And then we also have built this WPF adapter, and that includes controls like Kinect region. So think of Kinect region as this control that you would utilize that says, hey, anything within this area is, my word is connectify, right? This is where I can put my pressable buttons or my grippable area. We also give you the cursor, so that it's going to be consistent looking. It's going to fill and do those nice animations that we showed. And then we also give you those controls, that user view control and some other things there. So the other thing that this WPF adapter is doing is it's implementing the iInteraction client, and it's giving us the hit testing for our app. And it basically then translates those into WPF events that then our app can utilize and respond to. So here's the architecture diagram that I was just kind of talking to on the last slide. So the dark blue box and then the two purple boxes are what we built and shipped in 1.7. So again, you can use that native COM layer if you wanted to build something in C++. The sort of dotted boxes indicate like that's work that you have to do. Those would be an adapter that you or somebody else would have to write. But it is definitely possible to have a C++ DirectX app or a Win32 app. And then if you wanted to do something with XNA or WinForms and a managed app, you could use our managed wrapper. And then the dark blue box, again, are those controls in that that's the UI framework adapter there for WPF and those controls. Here's a UML diagram of how you would work with interaction stream. So the first thing that your application has to do is it creates the interaction stream object. And then your app would call two methods asynchronously, process depth and process skeleton. And so then the interaction stream then calls a method get interaction info at location, and then it returns back for an XY point. Is there a grip target there? Is there a press target there? If it's a press target, what's the center point of that press target? So again, our framework adapter knows then how to animate the cursor to have that centering effect as we push in. So it returns that info back, and then you get the callback to your application is interaction frame ready, and then you can again respond to that. So some considerations with the interactions. The Kinect, the current technology that we have, we can see 6 people, and we can actually give you outlines for 6 people at any time, but we can only give you 2 skeletons, 2 full skeletons for 2 people. And so we actually can give you, for those 2 skeletons that we can track, both hands. So the interaction stream gives you 4 hands total, a left and a right hand for both users, basically. The primary user in the primary hand is implemented by the Kinect region, and if you notice that in the interaction gallery, it was always one-handed. And our guidance from a UX perspective is to avoid two-handed gestures. I'm not saying don't do it, but just try to avoid them if you can, because they can be hard for users to learn, and they can be frustrating, and it's hard to educate them and whatnot. So we actually implemented an interactions gallery that if I'm using my right hand and I raise my left, we're just ignoring all the data that's coming back from the interaction stream for that left hand, unless I drop my right, and then I can take over, or I can switch between hands. So the cursor, again, I think I've said this a couple times, the continuous feedback is really important, and the initiating that on release, again, giving the ability to cancel that, similar to the mouse. And then that pressable button affordance that I showed in the controls gallery, where as I moved over those buttons, there was an animation. So again, it gives feedback that I know how to, that I know I can do something there. So now I want to move into, now that we've talked through that, I want to move in and give a sneak peek of our 1.8 SDK that's going to ship in September. So with that, I'm going to bring up a sample here. Everybody here familiar with the concept of green screening? Yeah, so you have a green screen and some expensive equipment, and you can basically make it look like you're anywhere. We actually ship a sample today. We've shipped it for a while that we call green screening. It's actually kind of misnamed. It should probably be called coordinate mapping, because basically what the sample does is it takes the depth feed, or the depth stream, and the color stream, and it just maps them on top of each other. And you can see here, the quality is not so great. My ear's cut off, my hair, my hair's all wavy. I don't have much hair, but it's still all wavy, my head. So again, the quality's not so great. And so we hear from a lot of our customers and our TAP partners that they want to have a better, more robust way to do background removal. And so I'm going to toggle the algorithm here. So this is actually the new background removal API that we're shipping in 1.8. So you can see the fingers still have some waves in there, but my head is relatively smooth. Everything just looks a lot cleaner and sharper. So we've actually done work to go in and do some nice, cleaning and detecting and trying to have this work better than what we have today, again, with just a coordinate mapping. And we do expect that, by the time we get to September when we ship this, even for what I'm showing right now, we expect the quality to improve. We expect the edges to be sharper, and there can be extra pixels that'll show up around me and whatnot. Now, you might be thinking that it's really easy for me to show hair, because hair is really hard to do when you're trying to do background removal. And so you might be thinking, oh, they sent this guy because he's the bald guy on the team. But you can see here that actually, if I get down here, there's some artifacts there. Let me, again, we're going to improve the Well, that got totally broken. Lance, I think you cursed me earlier when you said the demo gods. I didn't give my offering up. So anyway, you can see here, I mean, the hair actually comes in pretty well, and this stuff here is a known issue that we're dealing with, but we expect that to be all cleaned up in September. What's that? Good looking. Well, this is actually a surfer dude wig. Yeah. So background removal API coming in the 1.8 release. So I want to show another application that I'm actually working on personally. So I'm going to start this up. So I just started up a server here. And I'm going to go over to this. I'm going to refresh. So this app I'm building, I'm calling it Photobomber. So what I want to be able to do is I actually want to be able to connect to the Facebook APIs. And I've actually done a local version here because the Facebook API is a little bit flaky right now. But I want to be able to connect into Facebook, select a friend, get all their photos they posted on Facebook, and then I want to background removal myself into their photo so I can photobomb it, and then I want to post it back to their wall on Facebook. So this is that's the scenario. And so here we are. This is a web application. So again, this is another thing that we're doing in 1.8 where we're bringing Kinect and all the interaction stream work to HTML5 and JavaScript developers. So you don't have to go and learn WPF or .NET or some new foreign language. You know, you can use what you're already doing here. So you can see, and again, this is my UI. I'm not a UX designer, so I know I have work to do on the UI here. But I can, again, I have this button affordance so you can see what's pressable. I could go over here, my friend Brandon. I can choose him. I can choose one of his photos. He was really happy about this. There was a bug there. I didn't have the visual feedback enabled. But the idea here is then I would, once we ship 1.8 and we have the background removal piped into HTML, I could then show up right here on the screen, and then I could pose, and then I can merge those two images together. And again, photobomb Brandon without him having any idea right to his wall on Facebook. So just a fun app that I'm working on again for myself. So I think I want to show the, I just want to show a little bit. So what we're doing with this HTML5 and JavaScript is we're essentially giving you some CSS, some JavaScript, and some basic structure. So my app is actually fairly, my HTML is fairly basic. We essentially have this interaction ID, and this is where interactions are going to happen, and I'm going to put my images and whatnot. And then I've got this Kinect interaction JavaScript, and this is just this is essentially getting all of that data. You saw the server that I started up over here. What we're doing is it's designed to run on localhost. We actually built this primarily for a lot of our customers who want to build kiosks, and they want to have they want to use their HTML skills and build interactive kiosks. So what we're doing is this server is connecting to the Kinect runtime. It's getting all those data streams, and then it's piping all that over WebSockets to localhost for my web application to work. And so we're delivering back, like I said, some JavaScript and CSS, and there'll be an app. We'll say like, hey, here's how you should design it to work. But again, bringing that full interactivity of the interaction stream. So there was the background removal and photobomber. So now with 1.8, our architecture diagram is going to look like this. So we've actually now added those two boxes on the top right. So you can now build your own HTML5 and JavaScript app with some controls that we're giving you, and this web server that we're going to be delivering as part of 1.8. So that becomes that the adapter there. We did a blog post yesterday, and we announced that 1.8 is coming in September. So the two things I just demoed, background removal API, HTML5 and JavaScript support, and then I mentioned Chris White's session at 5. He's going to be showing something that we're calling Kinect Fusion Color, as well as he's going to be showing the new Kinect sensor and some of the scenarios that's going to enable. And there's going to be more in the release. We just haven't announced it at all yet. So speaking of the new Kinect, you probably, if you've been paying attention to what we've been saying about the new Xbox One, we know that the new Kinect has a wider field of view, has HD resolution. So the current resolution on the color camera on this one's 640 by 480, so full 1080p resolution. We can track 6 skeletons with the new sensor instead of the 2 that we do today. And it has better skeletal tracking. Actually, instead of 20 skeletal joints, we have 25. The skeleton's more anatomically correct and more stable, less jitter. The audio's better, the infrared is better, cleaner, more high resolution. And my team has announced that there will be a new Kinect for Windows sensor coming next year. So yesterday we announced a new developer kit program, because we know there's a lot of developers like you guys who you come to these events and you want to be on the cutting edge and part of what's new. And so the developer kit program is going to give direct access to our engineering team through private forum as well as private webcasts. And so this will be for troubleshooting, bugs, that kind of thing, feedback with the engineering team. The program also is going to have exclusive access to pre-release SDKs. So with the new sensor, we're going to build and ship a new SDK. And you'll get access to the alpha SDK, and then any updates that we do as we march to RTM next year. Private access to all the APIs and sample documents. You also, if you're part of this program, you get a pre-release alpha sensor. And then when we RTM next year, you get a new RTM sensor sent to you as well. So we're going to launch this program. It's going to start in November. The program fee is $399. And since we announced this, there's been a lot of speculation online. I was reading some of the comments on ours and some of the other places where people are talking about this, and people are all speculating, like, what does the price mean? It doesn't mean anything, right? This is a price where we want to be able to cover our costs for the hardware. Pre-release hardware is more expensive to manufacture because we're not doing a big run of them, obviously. So we think that this is, it's a great deal. It allows you to get in on the cutting edge early and have applications ready to go when we RTM the new sensor next year. So there's a link there. I'll have that link up at the end of the talk. But we would love for you guys to apply. We're going to be looking for developers who have really cool ideas for Kinect or NUI experiences. We're going to give preference to people who have experience already with Kinect or NUI and people who have really strong community involvement. So if you want to talk about this more later, grab me. Would love to hear your thoughts on this. So the people who should apply, maybe your organization is already working on something with Kinect or in the NUI space, or you want to experiment, or you want to help push the boundaries, or you're a developer and you've been working on something for you're experienced dev and you want to get into something new, or you just have a really cool idea. I mean, basically, we're looking for committed, passionate developers to give us feedback and help us keep pushing the boundaries and pushing NUI into the future. So that's basically the content that I have. I wanted to save time at the end for Q&A, but this is what I'm asking you guys to do. If you haven't already, get started with Kinect today. We have an amazing SDK that we shipped in March, which is 1.7. You can download that and get started. Most of the things, some of the things that we're hearing from people is like, oh, I'm just going to wait for the new sensor to come out. I will bet dollars to donuts that most of the things that you want to do are going to work with our current tech. They'll get better with the new tech, but most of the things that people want to do will work with what we have today. Follow our blog. Keep up to date with our, when 1.8 comes out. And if you're interested in being part of an early adopter program, apply for that dev kit program. We've got, this clicker is a little bad. We've got a booth. If you haven't been by the booth yet, come by, talk to us, hang out, ask us questions. We've got 3D printing demos happening from scans with Kinect Fusion. We've got a partner down there with an awesome retail experience that they've built using Kinect. And then check out Allison's talk from yesterday, or come to Chris's talk later today at 5 o'clock. So that's it. I'm going to leave this resources page up for you if you want to jot down any of these URLs, and I'll open it up to Q&A. Now, I will probably be able to hear your questions fine, but people who watch this later online won't. So please, there's 3 microphones here in the aisleways. If you would use those for questions, that would be great.
Yeah, so one quick question about Windows Store apps and compatibility with the Kinect for Windows.
Yeah.
So is that on your roadmap? And if so, what are the challenges that have prevented the Kinect SDK from working well with Windows Store apps to date?
Yeah, it's a good question. The question is essentially like, hey, when is Kinect for Windows going to work with Windows Store, basically, right? Steve, right? Yeah. So it's definitely on our roadmap. It's definitely something that we're working on, and we're definitely hearing it more and more from developers as Windows 8 continues to gain traction. So definitely we want to be there. I would say the thing that's limited us is that when Windows 8 shipped, if you're familiar with their app model, there's more of a sandboxing model there, right? And so it just hasn't been technically all put together for us to pipe all of those data streams into that sort of sandboxed environment. So again, I feel your pain. It's something that my team is very focused on and very interested in addressing, and we're working with the Windows team to figure out the right way to make that work. Yeah, Lance.
So I had a colleague that was looking at doing some Xbox indie games, and he was told that you can't use the Kinect with those games. First of all, is that accurate? And second of all, is that going to change?
Yes, it is accurate. There's kind of a the model with Xbox today, right? Is that it's a fairly curated environment. I mean, part of it I think comes from that if you're going to make a blockbuster console title, it requires tons of investment, right? So those companies that build those apps, they can use Kinect if they choose. Then, as far as like indie games go, I don't know the reasons why, but it's not enabled for those developers today. Will it happen in the future? I don't know the answer to that. Yeah, I mean, I think that if you look at what we're doing as a company, I think that we're starting and we're doing a better job of aligning the opportunity for developers across multiple platforms, right? So Windows Phone 7 shipped, Windows 8, took some of those same concepts, and I think we're seeing that more of a unified experience across our different platforms, not only for consumers but also developers. So I think that we'll continue to go in that direction. But as far as that specific, like, indie games getting Kinect, I don't know the answer. I mean, I'm with you. I hope we can figure that out. I will. Yes?
I just had a quick question. So the gestures that you showed earlier were all people standing as if they were standing in front of the TV, but this is for Kinect for Windows, right? So
yes.
For someone who has a Surface and some developer writes an application with Kinect for Windows, how are the gestures, like, because the area of view is limited to the face, then you can't really necessarily use a hand to do stuff except pagination maybe. So how do you plan to solve that kind of problems?
Well, I think there's maybe kind of two questions there.
Mm-hmm.
One is that I'm hearing is, what do you do when someone's not standing, per se?
Right.
And then what do you do specifically to
For
like
the
a Surface, smaller form factor?
Yeah, exactly.
So we have a seated skeleton mode in our SDK that you can implement in your app. I didn't show that today, but you can get the upper 10 points of the body in the seated skeleton mode. So this is exactly designed for, hey, if I'm at my desk and I'm not standing up, can I still do some sort of swiping or press or interactions in that way? So that's definitely available today.
Okay.
As far as something like the Surface goes, Yeah, it's something that we're very interested in, and we're thinking about, like, how do we make it work? But the reality is that our current sensor is going to look a little weird if you were to put this on top of your Surface. So it's possible, like you could set this on a stand or something like that, but we frankly think that we have, more work to do in terms of figuring out, like, what's the right, does the form factor change? What are those scenarios? And, it's going to continue to be an evolution.
Yeah, do you see these apps being ported to the Xbox One in the future?
It's a good question. I don't know if, I mean, you could, if you were a developer that had access to, building things on Xbox One, I'm sure you could reuse a lot of the same code because, we allow you to use C++, DirectX, so you could do code reuse, but I don't know if there would be a exact, hey, I just take this code and it just works over on this other environment. I think there are going to be tweaks and optimizations at a minimum that you would have to do.
All right, thank you.
You're welcome.
So yesterday we saw a demo of the Windows tablets where they were able to swipe pages on the tablets. Is this something that Kinect can also somehow integrate into the tablets?
Yeah, actually I was watching the keynote and the broadcast I was watching cut out, so I didn't see that, but I've heard people have asked me since about that. And I think Windows did their own thing there, and I haven't been briefed on what they did exactly. But we've had, there are people who have put code up on CodePlex where they're taking our SDK and they're building in these types of, things on top of Windows to add their kind of own interactivity. I think the challenge that we see with those things that have come from the community is they're cool, but they don't always have the right level of consistency or the right level of working with everything else. So I guess the short answer is I don't know what Windows did exactly, but I do think that, we'll continue to work across the company and figure out how and where should we align things.
Thanks.
Yep. Yes.
Yes. Some of the early samples that were initially released for the Kinect SDK relied on the XNA gaming engine. And I was curious to know if future versions of the SDK are going to have similar 3D sampling that are based on whatever the successor to that is, or other models of 3D interaction, not for independent gaming, but for any application.
It's a good question. I don't know. Anson, do you know the answer to that?
I was just curious because we were actually using it for kind of, like you were mentioning before, business applications for just kind of entertaining booth drawing applications. But using that, leveraging that as an example, will have diminishing returns and usefulness if the XNA gaming engine isn't supported in the future. So Direct3D is an example. All those examples rely on C++ and were primarily C#. So there would be a benefit there if there was an easy C# 3D method.
Cool. Yeah, and so just for the people who are watching online, what Anson answered was that the only sample that we've shipped that makes use of XNA is our Avateering sample, and that our other kind of 3D samples that we have used C++ and DirectX. Yes.
Yeah, if you wouldn't mind, I want to sneak two questions in on you. First one is, using the old SDK, I actually wrote a program to do a button push like that, and the biggest problem that I had was mapping the coordinates of where my hand was into the coordinates on the screen and finding whatever. I mean, is that kind of all given to you now in the new SDK, or do you still have to do all the technical jiggery-poopery?
Technical jittery poopery?
Yeah.
No, you don't have to.
That's my term for
You
it.
don't have to do any of that actually
Okay.
with the new interactions that we've shipped. It's taken care of for you. If you were to go down the path, remember my architecture diagram where I had the dotted boxes? If you were to go down the path of say, hey, I want to do something in C++, you would have to come up with your own adapter to basically map the hand position to the coordinate system in your UI, your UI framework that we're using. But if you use WPF, what we've shipped today and what I showed today, that's all taken care of for you.
Nice. Second question was, you know, is the new Kinect going to change anything about the field of the optimum field that it works in? Because the current one, in an office environment where you got people sitting and they tend to put cameras very close to their chairs, it doesn't really work that well. I mean, people have to stand up and, you know, back away from it to make it work.
Yeah, so one of the things that we did when we shipped Kinect for Windows that was different from the Kinect for Xbox 360 is we actually enabled a near mode that you can
Right.
toggle on in your app.
But that's still kind of close for people that, because, you know, if you think about where people put cameras, they're like on their screens and stuff.
Oh, you're talking about just like a as a webcam. Yeah,
Yeah.
near mode might still be a little. You might have to get a little farther away than you would normally get, I think is what you're saying.
Okay.
The new sensor has a better field of view, and I think that the range is going to be I think you can get a little bit closer on the new sensor. Is that right, Chris? Okay, so you're still going to have about the same distance for near mode with the new sensor, but the field of view is improved. And then there was a gal that asked a question a moment ago, and I told her about the seated skeleton. I don't know if you've experimented with that at all. Has that addressed any of the issues of people having to get up out of their seat?
Well,
or?
I mean, it helps in terms of, you know, being in a cubicle. People don't have to back 10 feet away, or which you can't do. You know, you get far enough away, but you still can't just. Like I say, most people tend to put their cameras very close to their screen so that they can look at both of them and, you know, gesture, and that's really too close for optimal recognition by the Kinect.
Yeah, well, maybe we could talk after we close. I'd love to hear more about exactly what you guys are, what you're building, and see if we could figure out a way to make it work better. Yes.
So are there any plans on merging the Kinect for Xbox and the Kinect for Windows to have essentially one device? Like, because when the Kinect for the old original Kinect came out, you know, like I got one, I went plug it into Windows, and I'm like, oh, okay, well, why can't I go stick it in my PC, which is also hooked up to my big TV, and start playing around and doing stuff? Just as, like, because in Australia, the Kinect for Windows only, you know, one person was a stockist, and it was really only to go and collect for devs. It wasn't available for, you know, general population.
Yeah.
Not sure what it was like over here in the States.
Yeah.
Yeah, is there any plan to, like, merge the devices to make it easier for people to access?
Well, I think I'm going to answer your question in a couple different ways. One, I think we obviously could have done a better job, and you're not the first Aussie who's told me that it was impossible to find Kinect for Windows down there. So I think we screwed up on the distribution and making sure that there was enough, there were enough units there for the demand, right? So I think that's obviously something we need to do better. But as far as like merging them into the one sensor, the plan for the new sensor for the Kinect for Xbox One and the new Kinect for Windows sensor is for them to be distinctly different. And the situation that you mentioned about you were able to plug your Xbox sensor in, I think that was kind of an unintended benefit. Because if you saw how the Kinect hardware evolved, we used to have to plug the Kinect in via USB, and you had to have this external power adapter to power the Kinect for Xbox. But then when we got the new slimmer Xbox model, we put in a new port that was able to handle the data as well as power the Kinect. And that was a much better experience for users, a single cable, right? And for the Xbox scenario, that worked great. The downside was that for developers like you who were like, hey, I could have just plugged it in, that wasn't really an option anymore unless you got that dongle adapter. So no, the plan is have them be separate. We do additional testing with the Kinect for Xbox Windows to make sure that it works across a wide array of USB controllers. Obviously, the Kinect for Xbox, it's tested to work with the Xbox. It's a known environment that's repeatable across every unit. Yep. So I don't see anybody else rushing up to the mics. Don't be shy if you have any more questions. Happy to hang out up here afterwards if you have anything else you'd like to talk about. So thank you very much for coming, and appreciate the questions and the interest.